The James Webb Space Telescope, also called Webb, is a large space-based observatory, optimized for infrared wavelengths, which will complement and extend the discoveries of the Hubble Space Telescope. It will have longer wavelength coverage and greatly improved sensitivity. The longer wavelengths enable Webb to look further back in time to find the first galaxies that formed in the early universe, and to peer inside dust clouds where stars and planetary systems are forming today. This space-based observatory is named after James E. Webb, 1906-1992, NASA's second administrator. Webb is best known for leading Apollo, a series of lunar exploration programs that landed the first humans on the moon. The Webb is designed to look deeper into space to see the earliest stars and galaxies that formed in the universe, and to look deep into nearby dust clouds to study the formation of stars and planets. In order to do this, Webb will have a much larger primary mirror than Hubble, 2.7 times larger in diameter, or about 6 times larger in area, giving it more light-gathering power. It also will have infrared instruments with longer wavelength coverage and greatly improved sensitivity than Hubble. Also, Webb will operate much farther from Earth, maintaining its extremely cold operating temperature, stable pointing, and higher observing efficiency than with the Earth orbiting Hubble. Webb will be launched on an Ariane 5 Eco rocket. The launch vehicle is part of the European contribution to the mission. Webb is designed to have a mission lifetime of not less than 5.5 years after launch, with the goal of having a lifetime greater than 10 years. The lifetime is ultimately limited by the amount of fuel used for maintaining the orbit, and by proper functioning in orbit of the spacecraft and instruments. Webb will carry fuel for a 10-year lifetime, with margin. The project will perform mission assurance testing of the flight system, to guarantee 5 years of scientific operations, starting at the end of the commissioning period, 6 months after launch. The most important size of a telescope is the diameter of the primary mirror, which is approximately 6.5 meters, 21.3 feet. This is about 2.75 times larger in diameter than Hubble, or about 6 times larger in area. The Webb will have a mass of approximately 6,500 kilograms, with a weight of 14,300 pounds on Earth. In orbit, everything is weightless, a little more than half the mass of Hubble. The largest structure of Webb will be a sunshade, which must be able to shield the deployed primary mirror and the tower that holds the secondary mirror. The sunshade is approximately the size of a tennis court. Each successive layer of the sun shield is cooler than the sun shield. The heat radiates out from between the layers, and the vacuum between the layers is a very good insulator. One big thick sun shield would conduct the heat from the bottom to the top, more than 5 layers separated by a vacuum. The Webb will send science and engineering data to Earth using a high-frequency radio transmitter. Large radio antennas that are part of the NASA Deep Space Network will receive the signals and forward them to the Webb Science and Operations Center at the Space Telescope Science Institute in Baltimore, Maryland, USA. The Webb will orbit around the second Lagrange, 2 Lyrae point, which is about 1 million miles, 1.5 million kilometers, away from Earth, and it takes about a month to travel this distance. During the trip to 2 Lyrae, Webb will be fully deployed, will cool down to its operating temperature, and its systems will begin to be checked out and adjusted. These checkout procedures will continue until 6 months after launch, at which point routine scientific operations will begin. Webb needs to have an unfolding mirror because the mirror is so large that it otherwise cannot fit in the launch shroud of currently available rockets. The mirror has to be large in order to see the faint light from the first star-forming regions, and to see very small details at infrared wavelengths. Designing, building, and operating a mirror that unfolds is one of the major technological developments of Webb. Unfolding mirrors will be necessary for future missions requiring even larger mirrors, and will find application in other scientific, civil and military space missions. The Webb has 4 mission science goals. Search for the first galaxies or luminous objects that formed after the Big Bang. Determine how galaxies evolved from their formation until the present. Observe the formation of stars from the first stages to the formation of planetary systems. Measure the physical and chemical properties of planetary systems, and investigate the potential for life in those systems.